All right, we are going to hop on to 7.1, the first day of it, which was an Ed Puzzled Notes. If you're listening to the video and you have me, Mrs. LaRude, mine go in as notes assessments when I Ed Puzzle them, so you should definitely do that. Anyway, we're going to hit the last one because I was just telling these guys in my first hour that there's 3 like this on the test. So I'm going to put a big star by it so you know to put something on your note card about it, okay? So when they give you a ratio, like if I were to say the ratio of boys to girls in this class is 2 to 3, that doesn't mean there's 2 boys and 3 girls, right? It means there's some multiple. Maybe there's 10 boys and 15 girls. It means it reduced. And so it means there's some common number that got chopped out and it reduced down. So you remember in your notes, those of you who watched it, I call it introduce X. So go, if you already have that written, great. If you didn't take the notes, this was at the very end and I had a question about it, but I forgot to hit save. So I saw some of you quit the notes before you got to this one, so that's why I want to hit it. So when I say introduce X, I mean tack an X onto each of these so that you write it as 3X to 5X to 6X. And then it'll tell you something about it. This is perimeter of a triangle. It might be the angles in a triangle. I think there's one on your test about 2 angles being either supplementary or complementary. So you need to remember those words. But this is the perimeter of a triangle, okay? And the sides aren't 3, 5, and 6. There's some multiple of them. Maybe it was 30, 50, and 60, all right? So perimeter means distance around, so we're just going to add those up and set it equal to, I crossed that out, what is it? 98, all right? And for those of you who already took the notes, I know you know how to solve that, so I'm not going to finish it. But I just want to make sure you know that you're to introduce X. So on a note card, I would make sure we'll start the note card later. All right, so we're going to pick up from here where we're going to work with proportions, which are 2 equal ratios. So go ahead and write that down. I really don't care less about all of this. I don't care if you know what the means are. I don't care if you know what the extremes are. It just messes up the issue, so don't even worry about it. All right? All I want you to do is think of it like you did in algebra. Do you guys remember how to solve these? Like when you have 2 equal fractions. Do you remember? I know I said I wasn't going to interact, but I actually want to. What do? Do you remember? I thought I saw your hand go up. Do you guys remember if you had to solve this, what you would do? I know some. You know. What if I did this? Do you remember what your teacher called it? Yep. Yeah, cross multiply. So when you solve a proportion, don't worry about means and extremes and all that stuff. We're just going to cross multiply. Or sometimes it'll be called setting the cross products equal. So when 2 fractions are equal, I'm going to go over here. I'm going to put a fraction that's exactly the same as 2/3. Good morning, honey. I'm going to put a fraction on here that's exactly the same as 2/3. And you'll notice on this fraction that when I multiply this diagonal, which is called the means, but it doesn't matter, I get an 18, and then when I multiply on that diagonal, I get an 18. If they're truly equal, the cross products are equal. So when you're trying to find a missing piece, you go 6 times 4 is 24, and you set it equal to 5 times x. And then you just solve it. So we'll divide by 5. Divide by 5. That doesn't go in nicely. If you used your calculator, I believe it'll give you a 4.8. So this is the one number in the world where if I put it right here, those fractions would be equal. Okay? So when you have like this, where you have 2 terms, lock it in parentheses. So go ahead and do that. And then you still set the cross products equal. So you're still going to say 3 times the y plus 4 is equal to the 9 times the y. You guys go ahead and solve that. I don't have a vibe for your algebra. Last semester, once I was confident their algebra was super strong, I would actually just skip these to give them homework time, which I'll eventually do with you guys. I just want to make sure I'm not skipping stuff you don't know how to do. So go ahead and make sure you got the algebra down for that. I'll kind of walk around. I don't know what the answer is. Got it? Yeah, that's correct. So for the first couple weeks here, I'll kind of walk around and see if our algebra is good. If it is, then I eventually just skip this and give you more homework. That's fair, right, Lil? Right? E? Yep, perfect. All right, they looked good. All the ones I saw, we had a y equaling, I didn't get to this side, so what'd you guys get on this side? Y equaling 2. You good? Yep, all right. So we distributed. And I am going to solve this one just because for some other classes that need these notes. Just in case. I got a good vibe from you guys. It looked good. You subtract that 3y from both sides. And you get 12 is equal to 6y. And then we divide by 6. So awesome. I don't feel the need to do this one because that looked good and you all did it. All right. You get how I kind of run things? It's like, if we get it, we don't need to do a zillion of them. All right. Let's do this last one, though. I would suggest you walk and load that in parentheses because that's the only thing usually that goes wrong with it. And let's grab, they are called the means. I don't care if you know that. Okay? These are called the extremes. Don't care if you know that. We're just going to do 15 times its other piece on the diagonal equals 3 times its other piece on the diagonal. And then we'll distribute that 3 in. Boom. Hippity, hoppity, distributed. Oh, I forgot a recording. Distributed property. All right. So we're going to distribute that in. And maybe I'll ask one of the Logans, who both aced their quiz, by the way. What do I do next? Funk. What'd you say? Yes. If you can't hear on the recording, you said, I think he said take away the 3m. I'll take it. What do I get? 12m. Equals 3. Be careful on this because a lot of times if I were to walk around the room, but I'm going to be lazy right now, I'll see lots of 4s. So be careful with that, all right? It's not 4, what would it be? 1/4, right? So just be careful that you don't like jump to that wrong conclusion, but that's how we solve a proportion. So let's move on to our next page. This looks like a lot of stuff on here, doesn't it? I don't write these notes. Sometimes first semester I did. I like to keep things at their most simple level so that it's not like so much stuff. So I'm actually going to cross all this off for you and I'm going to give you a little bit of maybe just some easier words to think of. When we have a proportion like this, I already told you that when you multiply across they're equal. But if you look at what happened to get from here to here, if you flip them over, they're equal. So I'm going to write the word flip right here. What it's saying basically is that if 2/3 equals 6/9, then if you flip them, 3/2 equals 9/6. So if you flip them, they're equal. That's easy, right? And then the next one says that you'll take a look at this one. It says A/C. I want you to draw an arrow. And we're just going to write, what would be a good word for that? Across? I don't know. Let's call that, you can flip and you can go across with them. So you can say A/C is B/D. Let's draw a double arrow because it's also true that C/A would equal D/B. So you can flip them, you can head across, and this tends to be the most difficult one for people to see. So I think the best thing to do is to circle this right here and right here so you can kind of sort it out. What's happening is they're adding the denominator to the top on both of them. Let me show you with a fraction. I'm going to use, let's do 1/2 equals 5/10. That's totally true. The cross products are both 10. What they're saying is this. If you add 2 to the top and add 10 to the top of that one, they're still equal. So you just kind of got to make sure you had the bottom gets added to the top of both. So we're going to go practice those. So there's four properties actually. The cross products are equal. You can flip them. You can add a cross, and you can add the denominator to both. So let's see what this one's having you do. It says in this diagram, x over 6 equals y over 7. And they are going to tell you to complete this, and you have to decide which one they did. Did they flip it? Did they add a cross? Or are they adding something to the top? And you're going to look at this, and you're going to go, oh, they're doing x over y. So what you're going to do is say, if you're going to do x over y, you're going to head across and do 6 over 7. What do you think? Yep, you're nodding, right? It's pretty straightforward if you kind of ignore all that stuff. You can flip them, you can head across, and you can add the denominator to the top. So let's go look at this one. I'm going to have you guys, we're going to take this one off of here. I'm going to have you guys see if you can do A and B. If you're watching the video, just pause it and go do A and B. Which of those, actually 4 properties, are they setting the cross products equal? Are they flipping it? Are they heading across? Or are they adding something, the denominator, to the top? There are 4 things. You have to decide which one they're doing, and you need to do the same. If something got flipped, you flip the other one. If they headed across, you head across on the other one. If they added the denominator to the top, you add the denominator to the top on the other one. Pretty straightforward. All right, normally I'd ask you guys, but because I'm recording, I'm just going to give you your thought process. You look at this, and you look at the one they gave you, and you ask yourself, did they flip it? And you say yes. So then you flip it, and you would put 7 over y. How many of you had that anyway? Okay, good. On this one, you look at it and you say, did they flip it? No. Did they head across and do x over y, and then I do 6 over 7? Nope. They added 7 to this side. So what you need to do is take your x over 6, right, and add 6 to it. That's the hardest one to spot. So make sure, the reason they're equal is because on both of these, that's just 1. Does that make sense? So you're really just adding 1 to both of them. All right, little review from yesterday, and then we're done. I like to keep notes short and sweet unless I feel like you don't understand it. So it says, to the nearest millimeter, a cell phone is 84 millimeters long, 46 millimeters wide, and it says, what's the, oh, Bloom. Bloom makes these notes. What's the ratio of the width to the length? So you're going to put a fraction bar down, because I like to use the fractions instead of the like colons. And it says width to length. So just make sure you don't do it upside down. You're going to put a 46 on the top. You're going to put an 84 on the bottom. If you didn't take yesterday's notes yet, you're going to in about 5 minutes. And you'll hear me talk about how you always have to have the same units. If you do, you just reduce the fraction. If you don't, you have to convert one, right? So you would reduce 46 over 84. Who's got, oh, you've got the fancy calculator out. Thank you. Do 46 divided by 84. Math, enter, enter. Or they're both even, so I'll at least take a 2 out while they're doing that. And that, actually, that's as far as it goes. All right? And you don't need to label, because you kind of can consider these canceling off once they're the same. So it's in a ratio of 23 to 42. I'm going to change this question so it's more similar to the one on your test. All right? So I'm going to put this, look, let's put a little carrot there. And I'm going to put, pick one, Bjorn, supplementary or complementary? Complementary. All right. Do you guys know what complementary means from first semester? If 2 angles are complementary, what do they add up to? Oh, I should get closer to my mic. But if they're supplementary, they add up to 180, right? They add, and you need to know both. So let's write that on the top here, and we'll remember to put it on our note card. Supplementary angles add up to 180. Complementary, I'm just going to put comp, add up to 90. So let's say to complementary, I'm just going to point at it, and I'll give you some time. I wrote that really fast. Two complementary angles are in a ratio of 5 to 9. We're going to cross this out. And we're going to say, what are their measures? Bam! I'll let you write that down. And I'm telling you, I'm really clear about what you're tested on. You'll have one on your test. I don't know if it's complementary or supplementary, to be honest. I haven't looked at it, but there'll be one. Okay? I said complementary on this, so your two angles have to add up to equal 90. They're in a ratio of 5 to 9. That doesn't mean that one of them's 5 degrees and the other's 9 degrees. That only adds up to 14, correct? So if you didn't watch the notes from yesterday, I did one like this, and I said you need to introduce that x that got chopped out. It reduced to 5/9. So one of them was 5 times something. The other was 9 times the same thing. So we get 14x equals 90. Will you do 90 divided by 14 on your calculator for me? Thank you, Preston. What do you get? What's 90 divided? It doesn't go in nicely. What is 6.42? 6.42. Okay, so if x is 6.42, he says, and if it says to find their measures, what would I do with the 6.42? Multiply by 5, and then multiply by 9. We don't need to do that. Okay, does that make sense, guys? So, good morning. All right, so we are going to be done. What I'm going to have you do, I'm going to stop the recording. We are done. I like to